Hello class. Today we're going to talk about finding volume of pyramids and cones. Okay, so let's dive off into the lesson here real quick. So our lesson today is going to be a PowerPoint, so just bear with me as I get this set up. Okay, so here we go. Today we want to learn to find the volume of pyramids and cones. So we've got two vocabulary words that we're going to work with, pyramid and cone. First thing we need to do is make sure that we understand what a pyramid and a cone really are. Pyramids and cones have a parent figure. That parent figure is a prism or a cylinder. So both of these are going to be named by their base. So in this one, we've got a rectangular pyramid. Well, its parent figure is a rectangular prism. Triangular pyramid, its parent figure is a triangular prism. And the cone, of course, its parent figure is a cylinder. Now, the one big difference between a pyramid and a prism, or a cone and a cylinder, is that in a pyramid or a cone, you only have one base. Okay, only one base, and they always come to a point. So we need to remember that the biggest difference, and really the only difference between a pyramid and a prism is a prism has two bases that are parallel and congruent. In a pyramid, it only has one. Okay, so when we look at the definition of each of these, it says a pyramid is a three-dimensional figure whose base is a polygon, and all of the other faces are triangles. It is named for the shape of its base. A cone has a circular base. The height of a pyramid or a cone is measured from the highest point to the base along a perpendicular line. So in this rectangular pyramid here, we've got a rectangular base, so that's why we call it a rectangular pyramid. All the other faces are triangles. Okay? And the height is this perpendicular distance from the base to the farthest point away, which is the point. Same thing with the triangular pyramid and with the cone. Now, I've got one question for you, and I'm going to talk about that in a little video here. So just watch. Okay, in this video we're going to learn how many pyramids it takes to fill a rectangular prism. So here's our rectangular prism. Okay, this rectangular prism has a particular base and a height. So what I want to know is how many pyramids would it take if the pyramid has this as a base and this is a height? How many pyramids would it take to fill this box? Okay, if I took the pyramid and poured sand in it, dumped it in the box, how many pyramids will fit inside this box? Well, let's see. Now, here is one pyramid. Here is 2 and 3 pyramids. So 3 pyramids will fit in this rectangular prism. So with that in mind, we should be able to determine the volume of a pyramid or a cone. Since it takes 3 pyramids to fit into any one prism, its parent figure, to find the volume of a single pyramid, we find the volume of a prism, which we know is capital BH, and all we have to do is multiply by 1/3 or divide it by 3. So let's see if we can do a couple of questions. Here's our first question. The first thing that we have to do is we have to identify its shape. Well, this is a triangular pyramid. You'll notice on the bottom here we have a triangle and we have a height to this triangular pyramid. So I need you to think about this in two ways. Okay? The first way is I need you to separate out the pieces of the formula, because we know our formula is volume is equal to 1/3 capital BH. So the first thing I want us to focus on is this capital B, okay, which we know stands for area of the base. So if we look at this base, we know it's a triangle, so that means to find the area of this base, it's going to be base times height divided by 2. So now I substitute in my values to find my answer. So I know that the base of this triangle is 4 and the height is 7, because I know the base and height are always going to be touched by a right angle, and it's going to be on one of the edges. So we would take our 4, multiply by 7, and then divide that by 2. So 4 times 7 is 28, divided by 2 gives us 14 centimeters squared because it's an area. Now that I know what capital B is, I can plug it in to this space right here where B is at. So volume is equal to 1/3. Well, the B is 14. And the height is going to be that distance from the base to the point directly above it, that perpendicular distance above, okay, which is 6. So then we take our calculator. Let me get my calculator here. Okay, get our calculator and we multiply 14 times 6, and then we divide that by 3 because multiplying by 1/3 is the same thing as dividing by 3. And that gives us 28 centimeters cubed. So focus on the base, find the area of its base, and then plug that into the capital B. Okay, so let's zip through the answers to these. I did all this work already with my work. Now let's do one more. So here is a cylinder. Okay, now a cylinder, okay, what kind of a base does it have? It has a circle base. So in this one, what I want to do, instead of using the formula right here, 1/3 capital BH, I want to actually start with the specific formula that we can use. So we know this B right here is nothing but a variable, and I'm going to plug in a formula to it. So in this problem, we got volume is equal to 1/3 times, well, what kind of a base does this shape have? Well, since it's a cone, it has a circular base. So I'm going to plug in the circle formula, which is pi r squared times, and then now times how tall it is, which is the height. So now we plug in our values. 1/3 times, well, pi we use 3.144 times, now the radius, remember, is a distance that is halfway across the circle. So that's what this 3 is. If they gave you the entire distance, that would be a diameter, and you would need to divide it by 2. So times 3 times 3 times, and now I need that perpendicular distance from the base to the furthest point away from the base, which is 10. So now volume is equal to 1/3 times, and now I type in my values, 3.14 times 3 times 3 times 10, and I end up with 282.6. Now, the biggest mistake people will make on a pyramid or a cone is they will forget to divide by 3. So please do not forget to divide by 3. And we get a volume approximately equal to 94.2 inches cubed. And that's how you find the volume of a pyramid or a cone.